All right, hey everybody. So today we're going to talk about OSC, which is an acronym for Open Sound Control. It's a networked data communication protocol that was developed in the 90s, I believe, and published in the early 2000s. It is, in a sense, a sibling of MIDI. It's a communication protocol which was developed to allow devices, perhaps those of a musical nature, to easily and reliably exchange information, and much in the same way that MIDI was designed to allow hybrid analog digital synthesizers in the 80s to more easily talk to each other. And so you can play one MIDI synthesizer and another one plays along with it. So OSC, by contrast, is it's more flexible, I suppose, in terms of namespace. Now with MIDI, you're stuck with specific categories of messages, which are called note on, note off, control change, etc. In OSC, it's a little bit more of a choose your own adventure. You get to choose the labels for all of your messages, and they involve a sort of URL address style tag system. You're also limited. You're not limited by the sort of 2 to the power of 7 discrete integers as well. You can send floats and different data types. OSC messages also have the ability to have a timestamp associated with them, so it allows for very fine timing precision. OSC, at the very beginning of this semester, you might remember that I said that SuperCollider is actually multiple programs that kind of masquerade as a single unified program. So specifically, there's the language, SC Lang, and there's the server application, which is SC Synth. And they can run separately. And whenever you do anything in the language which makes sound, and then there's also some instances of things which happen on the server where information comes back to the language, OSC is what enables, it's the crucial connective tissue between these two applications. And it's also what allows you to theoretically control the audio server from a different application like Max MSP or Pure Data or Python or anything, as long as you have an application which is OSC compliant, which knows how to send and receive OSC data, then you can theoretically link it up with the server or the language. And OSC is also the backbone in a lot of networked performances, laptop ensembles, and things like that. So it's largely invisible to us as sort of good-natured SuperCollider users, but it's carrying a huge lift. This is going to be one of the more technical lectures, and I don't mean that like the content is technical. I mean I have a lot of moving parts here, a lot of wires, a lot of things which I've rehearsed, and a lot of things which can just go horribly wrong. So I make no guarantees about the quality of this lecture, although I will do my best and hopefully everything goes well. The topics we're going to hit on today is we've talked about what OSC is. I want to introduce the two of the core OSC receiver objects that live in the language, OSC def and OSC func. They are very much the same in terms of design compared to MIDI def and MIDI func. Same concept. We'll do a little bit of exploration with an iOS app called TouchOSC. I have many videos on my channel demonstrating TouchOSC sending data to the language, the SuperCollider language, using the, I don't know if they call it Mark 1 or version 1.0 or something, the earlier version of TouchOSC where you actually build your interface on your laptop or desktop, and then you push the interface you've designed to your phone or iPad or whatever. And they've since released a newer version where you actually build the interface in the app, and so we'll try to do something basic with that. I'm still kind of I've just started using the newer version of TouchOSC like 2 days ago, so I'm pretty new to it. And then I'd like to this will involve some audience participation. I think normally I ask you to sort of close your laptops and just to kind of take notes as needed, but not follow along. But we'll try to rig up a very basic and crude, like a sort of laptop ensemble performance simulation, where I'm going to try to have all of you send me some OSC from your laptops, which I'll receive here in the language. And that I've done many times. And it is also possible to send OSC messages either explicitly by writing out the messages themselves, or indirectly by calling synths and playing patterns. such that OSC messages are sent directly to my instance of SC synth. And so you'll be, making synths which will appear on my node tree. I did try this with 2 computers in my office a couple days ago, and it worked for the most part. It raised a bunch of questions and sort of little details which I wasn't fully able to answer or explain, but we'll see how it goes. Okay. When we were talking about MIDI, we had MIDI func and MIDI def. And MIDI func is the object which receives MIDI messages, but you have to sort of give it its own variable name, and it's easy to accidentally overwrite one MIDI func with another, and then you have a redundant copy. The def version of this object, once you create a MIDI def with the same symbol, it overwrites the previous one, and there's no duplicate copy. So I find that OSC def is usually the one to use in practical settings, but we can say OSC func.trace true, and once this is evaluated, we will be posting in the post window every OSC message that is received. And stuff starts to come in already, because whenever the server is booted, by default, it will send these status reply messages with some information which appears to be the sampling rate and some other things. Probably this is like number of groups, number of nodes, something like that. I'm actually, there's a way to disable this. I'm not sure what it is off the top of my head, but we'll turn that off for now. And let's build a very basic OSC def. So just like MIDI def, we need to give this a name. We'll call this test, and we provide it with a function. And in the case of MIDI def, we declare some arguments that represent the components of a MIDI message, the value, the note number, the controller, whatever, right? So here we're just going to say the message. Right? The first thing that gets passed in is just going to be the message, and we'll say message.postln. And then, much in the same way that you can make a MIDI def respond to only a particular set of controller numbers or note numbers, we can do the same thing here and filter the OSC messages that come in. So we will only see OSC messages with a specific address tag. And I'm going to call this, I guess I'll just also call this /test. And this is the syntax that I see in the help files and which I've always used. So we want this to be a symbol. So we've seen a lot of symbols that look like look like this, with the backslash preceding the content of the symbol. And I'm pretty sure that OSC addresses need to start with a /, and this is a syntax that SuperCollider is just can't really handle. This will be an invalid expression for some reason. The backslash followed by the /. Like, this is maybe not allowed in I'm not really sure, but we can fix this by just using the alternate symbol syntax, which is to enclose the symbol that we want in single quotes. So we will run this, and so now if somebody sends this computer an OSC message with the address test, then we should see it in the post window. So I'm going to do the most trivial thing here and just send myself an OSC message. So the first thing I need to do is make an object which represents the instance of the SuperCollider language that is running on this computer. And OSC is a networking protocol, so I do need to be on a network, and I am on the Campus Illinois network right now. And you basically need to know 2 things. Well, I guess 3. We need to know the network, because the sending and receiving device need to be on the same networks, I think. I mean, maybe it's possible to send OSC around the world, but probably there's a lot of firewall stuff and who knows what else. But it certainly helps to be on the same network. And my computer is obviously on the same network as my computer, because we're just dealing with one device here. The other 2 things we need to know are the IP address, the local IP of the computer on the network, or whatever computing device, and the OSC port. Or maybe it's not an OSC port, just the port on which that device is listening. So I have my network preferences here, so I'm on Wi-Fi here. You can also do this over a physical connection, Ethernet or whatever. And we're going to go to network settings, and here is my local IP 10.195.31.59. So net address, net adder is the class which allows you to create instances of network devices. You know, in the language we have a representation of that device, and I'll call this me, Eli. Well, you know, I have the server and the language, so I'll say Eli Lang. And so we just need to provide the IP address. And because of the decimal points, you know, it's not a valid number, so we put it as a string, 10, 195, 31, 59. I think that's right. Double check. This is a common cause of problems if you just kind of mistype the IP address. And then the port can be confirmed by running netaddress.langport. And by default, the language listens for OSC messages on port 57120. It's probably possible to change this, but I don't think you'd ever really need to. Maybe there are some rare cases. So now I have an instance of my own instance of SC Lang. So I'm going to say Eli Lang dot send message, and we're just going to do a bunch of comma separated information. And the first thing in this comma separated list is the OSC address, right? So you know, this is like saying this is a note on message, and we have a note on MIDI def. We need to make these two things agree. And then we'll just send a random number between 10 and 99. Okay, so here we go. And there we go. It worked. So this right here is the side effect of just the post window always posting the result of whatever is returned, and what's returned by an instance of netaddress.sendMessage is just, you know, the net address itself. But you can also see that my OSC def has received this message. The address matched, and then it's just posting the entire message. So if I wanted just the number, I could, you know, not post the entire message and instead just say message@1.postln. Rerun this, send again, and now we just get that number every time. Right? And you know, this might actually be the right moment for you all to, or you know, at least one of you, to grab your laptop and make sure you are on Illinois Net. Create an instance of net address in your instance of SC Lang that represents me. So you can call it whatever you like, but this part should be exactly the same. And then send me a message. And just, you know, remember, this is going on YouTube, so be polite. Doesn't have to be a number. You can send a string, or you can just tell me how you're feeling about your day. You know, or just a number is fine. It's really whatever you like. So I'll clear the post window here and see how mine seems to be working still. And I'm only going to post the item at index 1 of your message. Yeah, you could send a longer OSC message, but we'd only see the item at index 1. Hey, all right. It worked. So somebody has said, hello, YouTube, anonymously. Tell you what, while you are all having fun sending me some messages, shout out to Carter Rice. Okay, let's. I'm gonna copy a synth-def from my. No, I'll just make a quick synth-def. So I'm just going to do and what I'm going to do is make sure this works. Okay, very good. And now I'm going to redefine my OSC message. So we'll still post the first thing, but I'm going to say if message at 2 dot is number. I think this is a thing I can do, right? That's true, but that's false. So if you happen to send me a number in index 2, then I will do synth tone freak message at 2 dot clip 20. Well, let's clip it down at 80 and 12,000. And let's just make sure this works. Yeah. And so okay, we're gonna run this, and so now you should be able to send me a message, something like hi and then 500. Right, so now we got a little rudimentary networked laptop performance where the only thing you can make is these percussively enveloped sine waves. Yeah. Well, let's spend a little time here. Just give everyone a chance to make some fun sounds. And you could do a little iteration block, make a chord. You could, I don't know, make a very basic routine. Put you all on your live coding game here.
I guess that's not how it decides to do chords. I gave it an array of values for index 2.
Yeah, an array is not a number, is the problem. Yeah. Yeah, so I could refine my conditional logic. Yeah, I could say if it is a number, put it in an array, and then treat everything as an array. But I mean, this, you just have to come to an agreement, between sender and receiver on the types of data you're sending and what to expect. This is great. Okay, it's okay. Okay, now we're cooking. Someone has made some sort of timed sequence.
Every time I update it,
Don't worry.
it's a new thing.
I have the, oh yeah. Okay. There we go. Got a little bass line in there. Let's do. See, I can turn it down by just redefining my synth def at any time. Here, this is what we're going to do. Now everyone gets an octave. Oh, uh-oh, too many nodes. Oh, you know what? That's my fault because so we'll do s.free all. Because I forgot to done action 2, my envelope. All right. Well, I ruined the party. My fault. But okay. So we'll OSC def test dot disable. Right. Just kind of switch that off. It's still like we could enable it if we want that again. Okay. Good. And I should have seen my server CPU numbers creeping up there. But anyway, we had a good time while it lasted, right? That was fun. Okay, so that is the gist of sending OSC from a remote computer to, from SC-lang to SC-lang on 2 different computers. You just need to know the IP address and port, and you just need to be on the same network, and then you're pretty much good to go. All right, so let's go on to TouchOSC, and so this is a I think an iOS and Android app where you design basic controllers with buttons and faders and such, and And let's see, I'm actually gonna, I want to do OSC func.trace true, and so I'm gonna quit the server here just so we don't have to deal with those server sent messages of the server reply. And okay, so now we come to, let's see if QuickTime will cooperate. Yes, okay. We have phone. So I've got TouchOSC kind of here in the middle. I also have the older version of TouchOSC, which I think was $5 on the App Store. This one is, I think, 14 or 15. And just to reiterate, I'm just getting the hang of this app. But what I'm going to do here is we're just going to use the plus button at the top here on the ribbon to make a button, and I will try to, always a little finicky to try to get it to, it's a very fine granularity of touch control here, and we'll make a fader as well. And just for fun, we'll select these, and I'm going to press and hold to copy and paste. And sure, one more. Why not? Okay. So we've made our interface, and we could save it and give it a name and things like that. But I'm just going to go straight over to the little pair of chain links here, second from the right. And this is where we go into our OSC connections. And I've already set this up ahead of time. Looks like it gives you the option for 10 different connections, so you can, from one controller send to multiple OSC destinations. So I've got the host, which is the IP address, and the send port. And we've got the connection enabled here with the checkbox. So I think we're good to go here. So I'm going to go done, and then I'm going to hit the play button up here in the ribbon to leave edit mode and go into performance mode, I guess. And I can just kind of, you can see I'm just tapping on the buttons here. So we've got, it's all very nice and responsive. So I'm sure there's a way to configure the specific addresses of these buttons if you want to sort of customize that. But what I usually do is just let them declare their own addresses. And so we'll say OSC func.trace true. And now, the moment of truth. Yes, so I push that button, and I'm holding it down, and we can see that a message has arrived with the address /button1 and a value of 1.0. I'm going to release it, and now we get another message with the same address and 0. So we can 10, 10, 10. This one has button 2, this one button 3. We have our fader, which is floats between 0 and 1, fader 1, fader 2, fader 3. Okay, so we've done our little debugging mode. We can switch this off. And let's just do something really simple here, where we have this button turn on or off a synth, and we'll make this one do volume control, I guess. So we want to say I guess we'll boot the server again. Gonna need that, and we're gonna you know what, we're gonna do an ADSR here, and we need a done action 2, or do we need a done action 2? Here I think I'm going to keep it 0. Done action 2, so that when the envelope is finished, we don't actually lose the synth. And we'll make a gate argument. And so now we have, you know what, I should keep this one so that so we don't lose it, but I will do this. And then we'll take this, move it down here, ADSR, 0, gate, KR, 0. We'll initialize the gate at 0 because the button is in an off state. that just to check this works. There we go. We've got a synth that kind of lives forever, and we can gate it on and off. And we are going to also need some amplitude control. We'll give it a very short lag time, just so there's a little bit of smoothness in changes to the amplitude. So now if we turn it on, we should be able to good. I know this is not very exciting, but you can use your imaginations on the many different kinds of OSC controllers you can create and the different parameters you can modulate. All right, so we've got that synth, and now we just need to make some OSC defs. So we'll call this on, off, message at 1. We just need to say synth gate message at 1, right? Because when the button is on, the value is 1, and so we can just use that explicitly as the gate call. And we need to give this, I believe it was button 1. And then we're going to say amp. Again, I think message at 1 is fine because this is a unipolar normalized value on the slider. Is it slider or fader? Does anyone remember?
Fader.
Fader, thank you. All right, let's give it a try. Yeah, that doesn't seem to be working. We have that. So let's see. If we do that, I'm not getting anything. Oh, well, that's definitely part of the problem. Yeah, that was why. Right, because I had created this one called on-off and then overwritten it with this one, which is only listening to the fader. So the button wasn't doing anything. My mistake. So now it should be working. We can turn it on and off. And then while that's being held down, riveting. A tone whose amplitude changes dynamically, such a thing has never been attempted. Okay. You know, a trivial example for sure, but I am here to inspire you all for your final projects should you wish to create something more complex and interesting with your many beautiful sounds. So, you know, we could there's so much to be explored here. I mean, there's in TouchOSC, if we hit that dot to go back here, you can see there's lots of other fascinating objects here. We'll get rid of those since we're not using them. And we have your radials, which just like faders, except a circle instead of a line. You know, again, I'm just kind of getting into this program. The XY is a two-dimensional slider. So this is going to give us, let's see what this actually looks like. Just where is my, this is what we want. We'll quit the server, print all OSC. Yeah, and so the message is XY1, and then we get X followed by Y. Yeah, and then we have the origin down here and the 0.11 over here. So pretty easy to very quickly see what is actually coming in and what the address is, and then it's just a matter of designing your receiver objects to do what you want them to do when something comes in. Pretty easy, right? So at least the in principle basics are all there. And I was asking before class started, how do you change the color? And in the little this little button here, we have lots of so here the various objects that we have, and then down here we have various parameters, sizes, colors, other. It just goes on and on, doesn't it? So I tend to not let myself get distracted with interface design, especially if I'm the only one who's going to be using it. I don't really need to. I don't feel the need to show off or make it super fancy, but you can go nuts, have fun. Yeah. Question.
What's the rate that the messages are sent at?
That's a great question. I'm not really sure the rate that OSC messages are sent. It might vary from software to software, and I'm sure some of them have rate limiting functions where you can maybe on the sending side and receiving side, but just based on what it feels like, it seems like whenever at least a pixel's amount of change is detected, it will send a new OSC message. Much in the same way that if you create a graphical slider in SuperCollider, you will notice that if you nudge it by 1 pixel, the action is performed. That's considered a change. So it may be the case that if you make like a slider, which is just a few pixels wide, then you only have a finite number of pieces of data that are sent because there's only so many pixels there. But if you make a really long slider, it might actually give you more granularity. So, but surely if you, I don't know, like if you, let's see, is it still on? Let me go into play mode here, and we just kind of zip it around. It seems like there is definitely, I mean, it might be an issue with the frame rate on the phone. Like the phone simply can't display those changes that quickly. Because we came from 0, the previous value was 0.21, and before that was 0.8. So I'm going to guess that it's limited by the frame rate of the device sending, if you're doing a graphical interface thing with TouchOSC. But don't quote me on that. I could be wrong. Okay, and anyway, that's pretty much TouchOSC. I think it's pretty easy to get the hang of it. So I would like to try something highly experimental here, and it may not work, and I may not be able to figure out why it's not working. Most of the time when I've done things with networked performances where I'm sort of doing audio things which rely on other things from other computers, what I usually do is, this thing, the thing we were doing with our little fun sine wave party earlier, where I just want people to send me OSC messages which I will receive in the language with an OSC def, because that way I can just use regular kind of code to parse that message, and I'm just writing a normal SuperCollider program, and often that program will then do things like create synths on the server and play patterns and stuff like that. And it is a little bit of a roundabout way of doing it because you're sort of sending data from one computer to another, and then from there relaying and translating from the language to the server. And so, the latency becomes maybe a little bit more of a concern. But it works reliably, and I've done it many times. And I think that's a perfectly legitimate way to go about a piece that involves that kind of networked communication. But it is also possible to set up a collection of laptops so that one person is running the server process, and that everyone else can go about their normal make a synth, play a pattern, whatever, and the sounds actually show up on the server computer. So I have dug into a file called server guide, and there was so there's a bunch of tutorials, for lack of a better word, which just kind of walk you through the process of using the server in various contexts. And then down at the bottom, it goes into local servers versus remote servers, and so-called multi-client configurations. And it gives you some, like make sure you do this, make sure you do that. And then there's an example which I've basically just copied. So this is on the machine running the server. This will be me. You set the network protocol to be TCP. I cannot explain to you why this is required and why UDP doesn't work. I'm not a network protocol expert. You need to set the bind address to be 0.0.0.0, which is what will then allow connections that are not from the language running on the local machine, and then you have to set a number of logins. And I've just done 10 here because that's more than enough for us here. So we're going to do this. I'm rebooting the server, and I'll untrue my OSC func. So supposedly I've now reconfigured my server to be friendly for this kind of setup. And what I would invite you all to do is to run this code on your computer. You create an instance of a new instance of server options. You are also using TCP. And then this is kind of the critical line here. You are going to create an instance, a server instance using server.remote. And so this, you give it a symbol name, just like you would with a synfdef. You give it an instance of net address that represents my computer. And take note that the port that the server listens to by default is 57110. The language listens on 57120, the server on 57110. And then you also supply that instance of server options so that when you create this server, it's using that protocol. You then connect to the net address object that represents the server, and then you run t dot, or whatever you called it, dot start a live thread. I don't know if this 0 is necessary, but I just kept it. And then this is I think this is technically optional. No, it might be necessary. I mean, the post ln is optional, but this is just a way of confirming by seeing something in the post window that you are connected, right? So because it recognizes that my server is booted, so we'll post this. I think this sets you up so that you'll receive the reply notifications, and this will, I think, give you your own default group on that server. So I'll give you all a minute to do this. And so whenever you've written all of this code, run it, and then just give me you're good, okay? Whenever you're done, the next thing to do is grab a synfdef. You know, it could be anything. Grab it from another homework or from just something, just something you want to test from another file somewhere. I'm assuming that this is fine. I think, how many people have run this code? Is it 4 of you? Okay, that's consistent with the number of notifies I have here, so I think that's good. So yeah, again, once you've done this, add a synfdef, one you're confident will not blow up or anything like that. And I'm gonna, this isn't going to work for me. I'm not going to run this code because I'm not supposed to be making an instance of a remote server. I have mine in S, and you'll have yours in T or whatever you used. But if you just say synth whatever, you can put your parameters in here. So I'm going to say my target is S. Oh, you know what? I changed it to have a gate. Oh, look at all that. Look at all those default groups. Okay. Did I make a synth here? I can't even scroll down anymore. Let's make that. Well, I'm going to say s.defaultgroup.freeall. And I'm going to go back to this version of tone. And this should make sound. Yeah. But what you should do, I think, is just say T. That's your target, instead of your localhost server or your local default group. Set it to be T, and this is where we will see if this. Yay! Oh my God, it worked! All right, and okay. So but yeah, this also happened. Yeah, so something is missing here, and what I think is happening is that you could try, well, no, the problem is that, well, okay, I'll do this, and then you should be able to make sound again. Every node has to have a unique ID. And from what I've read in these guide files, things should be going into your default groups, which were created when you joined, but they seem to all be going into my default group, and you all have your own node allocators. So there is something we can do, and so basically you're all using the same allocators, and so a bunch of you are trying to make a synth, and it's being given. That sounds nice. Like node ID 1001, 1002, and they can't both have the same number. So what we could do to be really sloppy here is I can't remember where this is. Okay, so is there a way to manually, okay, so we're just gonna have to try stuff here, and maybe it'll work. So if you say, like I think you'll say something like t dot new allocators. For me it would be s, but we somehow want to start, we want to offset the allocator so that it starts somewhere. Aha, this looks like it. So s dot, yeah, so what if I do ID offset? No, that doesn't work. Node allocator. Yeah, so if you all can maybe try to figure this out, bravo. I would need a minute or something. But basically we just want to configure your instance of sclang, I guess. So when you are making a new synth, have it start at like 10,000 or 20,000 or something. I mean, really you want these to be separated by a gigantic number, because you might be making a pattern that spills a ton of synths onto the, So and I think that's partly why these group ID numbers are so large. They're not like just 1, 2, 3 or whatever. I know we can do something like s dot send message s underscore new server reference. Oh yeah, this. So this is I think you can send a message here, and then you say that the name of your synth def, the node ID you want it to have. Like if I do tone, and then I'll say 10,000, and then what do these mean? Let's see. I'll find it. Okay, yeah, the synth name, the node ID, the add action, which probably doesn't matter too much. The target ID, you can just say 1. And then I think we do stuff like freak 500. Oh yeah, duplicate node ID, right, that's the problem. So, I don't know. That should be fine, right? This does not guarantee, but this is not the way to do it, right? Anyway, so now if you do this and send it to T, or whatever you called the remote server, then you're saying the tag of this OSC message is make a new synth, right? /s underscore new, name of synth def, node ID, which do whatever you need to do to try to avoid conflicts. This is add to head of the default group, and then any sort of parameter value pairs you want to do. So I could say like 5,000. Send. Oh, right. Well, I don't have a T, right? Does my synth def just not fade out? Is that what's going on here? Oh, you know, maybe I'm still using the one that doesn't have the percussive envelope. I'm just gonna wipe all those. There we go. And just want to be able to make some sound. So now, okay, here we go. Oh, I don't even know. Oh, I guess that was enveloped. It sounded like a command period, but I don't think command period works for any of you.
No, I tried.
Yeah.
I did an X dot free.
Yeah, if you name your sense, you can do that. And you should also be able to do t.send message. I think it is n_free, and then whatever node ID it has. I think you can also just free the default group, but that'll totally ruin the party because then I don't think anyone can, you know, just to, you know, I rarely work in this kind of a methodology here. So there are, you know, the language and the server are very well designed to partition out the node IDs to different users as they log in. So I'm obviously doing something wrong here. Not totally sure what it is, but at least now it's documented, and then I can maybe ask somebody on the forum, what did we do wrong? What did I do wrong? Okay. Well, anyway, I feel like that's really all I wanted to get through. You know, OSC as the concept, OSC def as a receiver, net address as your you know, representation of some OSC device on a network, TouchOSC, and then sending OSC to the language and to the server on someone else's computer. So I think we'll wrap up there. I think this was a mostly successful lecture. Nothing blew up, and I got my phone on screen and everything. So I guess that'll be it. We are going to talk about graphical user interfaces next week. So SuperCollider, we haven't seen any of it so far this semester, but it's got a big, rich library of GUI objects, you know, buttons, faders, much just like TouchOSC, but you can design them here in SuperCollider, and I'll try to cover the fundamentals of that as well, because that's an important part of certain types of projects. You know, if you're sending them to someone else, or you just want to emulate some fun piece of analog hardware. So that's what we'll do next week, and then fall break. And then I guess I'll figure out something to do on the last day of class. But just as a reminder, I want sort of a quick email from all of you on your plans. I've got it from one of you already for your final project. So just shoot me a quick email, very informal, just so I know you've got a direction and that sort of thing. All right. Thanks very much, and we'll see you next week.